Hi everyone, Zach here, and welcome to the prep video for lesson 26 in this series on developing a survival game. In this video, we will discuss some core OOP concepts and re-explore inheritance. This video and this series have been brought to you by Patreon sponsors. If you have not already, make sure to hit those like and subscribe buttons below. It really does help the channel out. And if you would like to take your support a step further, consider becoming a sponsor on Patreon. Patreon sponsors get access to project files for these YouTube series and early access to the videos. Alright, let's jump into what we're doing today. So in today's tutorial, we'll be creating our equipment system, which is very similar to our inventory system. In fact, most of the functions we're setting up will mirror those in our inventory system. We will also set up functions that allow us to move an item from our inventory to our equipment, and from our equipment back to our inventory. But today's prep, as I mentioned, is going to focus on OOP and inheritance. So let's talk about class. So what is a class? A class, simply put, is a blueprint. And quite literally in Unreal, we are working with blueprints, and the blueprint that we work with is a class. So there are different types of classes. There are different types of things that we can blueprint. But let's explore this a little bit further. So this is a blueprint. It's a framework that houses, we can see where this pun's probably going, variables, methods, and functions. And it's the instructions for whatever this class has to do, or simply put, it's the blueprint. It's the instructions for on which a house is built. Like I said, you can probably see where that analogy was going earlier. So it is the blueprint of an object. And again, in Unreal, it's quite literally a blueprint. So for example, we talked about this during abstraction. We have the concept of a car. And we can have a car class. It holds, the acceleration, it holds the engine type, it holds the number of doors that car has, it holds which direction the steering wheel is turned, etc., etc. But it isn't the car itself. For that, we have instances. So an instance is when a class is placed in the world. It is an instance of that class. So the object in the world is an instance of that class that we just created. So if we have a Grand Prix, 1993 Grand Prix, we place it in the world, that is the instance of the car class. So another way to think about this, though, is you and your friend may drive the same make and model car. You all might have Pontiac Grand Prix from 1993. I gotta stop using the car I first drove. Yet, despite you and your friend having the same car, it is not the same car. Same make and model, same whatever, but they are two different cars. One doesn't cease to exist if someone else gets into it. Both cars exist. So they are both instances of that car. So an object is an instance of a class. And an instance is the thing itself, the car. Your car, your friend's car, my car, that random person over there's car. I'm pointing at a wall. But that's how you need to think about it. So in C++, there's this bit of code known as this. In Unreal, when we do blueprints, this is self. So when I talk about this or self, they're fairly interchangeable. So self is a reference to the particular instance of a class. So you and your friends have the same make and model car. It's called one car A and the other one car B. If I said, if I got into car A and I said this car, I am referring to car A. If I get into car B and I say this car, I'm referring to car B. So it's that particular instance, that particular version of that object in the world. Another way to think about this would be, let's say we have 5 apples. And each apple has its own value to how much hunger it reduces. So one apple has a value of 2, another one has a value of 10, another one has a value of 3, another one's rotted, so it has a value of -1, what have you. Now, the character eats the third apple. Let's say this is the one with a value of 10. So what we need to do if you're thinking about our survival game is reduce the character's hunger by 10. So the third apple uses the interface to trigger the eat event that we have, and then it passes through that particular value that apple has. So that third apple has a value of 10. It's not the rotted one, doesn't have the -1. It isn't the really small one with a value of 2. It is a healthy and wholesome apple with that value of 10. It has to pass through its particular value to affect hunger. So we have to get a reference to self, or this particular apple, to achieve the effect we're looking for. All right, as I said, this is sort of a review on some OOP concepts, and we're going to re-explore inheritance now, so we can understand our system just slightly better. So in inheritance, let's say we have item master, and it has some variables and some methods. So in item master, we have the item structure that has the icon, the name, the description, if it's consumable, stackable, what have you. We have the amount that we're adding to the world, and then we have functions for what happens when we overlap the item, when we end overlap, and when we use the item. But this is an abstract class. There's no real value here to item master. So we then have a child. Now the child inherits from the parent. So item master is in white, food master is in blue. Food master inherits the item structure and the item amount from item master. It inherits the on overlap and on use. But we add a new value here, this food value. And you'll notice, though, that we get this food value here, but it isn't up here with our item master as well. It is only part of our food master, and that's because inheritance is a one-way system, going from the parent, passing these on down here, to the child. And the child's value, this food value here, isn't passed back up to the parent. So that's the first thing. We've already covered that. But not only do we get access to the variables and methods of the item master and food master, we are able to override those values. So we're able to override our item structure. We're able to override the item amount. We're able to override what happens when we use the item. And of course, again, as you know from earlier, our food master is an abstracted class. So we have to have yet another child. And so that takes us to this next step where we get our small herb. Again, notice the font colors. We inherit from our item master, the item structure, the item amount, the on overlap, the on use. We inherit from our food master the food value. But in this case, we can place this in the world. And again, notice that none of these values go back up to item master. We are also able to override, say, the food value or the item structure, which we would actually override as well. So remember, inheritance goes down from parent to child and does not go back up. Even in Blueprint, if you cannot see a variable in a child class, it's still there. And in fact, there are ways to make it display, but then you see everything it's inheriting. Or you can just search for it as we have in earlier videos. All right, that said, that brings us through what I wanted to discuss with you today. This series has been brought to you by my Patreon sponsors like Hanas, Rian, Quadmenton, and 1Vault10. I look forward to seeing you in the main tutorial, and I hope that you have a wonderful day.